Thank you for coming. In this talk, I will introduce the Uftrace tool, function graph tracer for Userspace and more.
You can just put it in the center here.
Let me introduce myself. My name is Namhyung. I'm working for LG Electronics. We have a small social contribution team and we want to work with the Userspace project. Most people work with the ESCOM project and some other related projects. First of all, please understand that my English is not fluent, so there may be some mistakes or something. Introduction. Uftrace is a function graph tracer, which is inspired by the Linux kernel trace. And it shows execution time of its function written in C or C++. But instead of targeting the old program, old processing in the system, it just focuses on a single process. And it needs some support from the compiler to its instrumentation code. And it currently supports x86, 64, and 32-bit systems. And it can also trace library calls and kernel functions. Uftrace is an open source project released on the GPL. You can download it from the page. So how it works? It uses fairly well-known techniques using compiler instrumentation with PG or F instrument functions. And it basically recommends to use PG option, but it's a bit less stable since it requires to replace the return address to look up the exit of the functions. But some programs access to the return address and some do little things. In that case, it might have some undefined behavior, so you need to use instrument functions for that program. So the instrumentation code is built into the lib and count library, and it will be loaded with LD preloads technique. And the lib and count basically writes the tracing data to the shared memory, and Uftrace reads the shared memory and writes it to the file. So this approach is sometimes useful since the target process might crash it in the middle, but we can still have the trace data since we have the Uftrace still can see the shared library of the program that did crash. So Uftrace consists of the following commands. Record and receives to save the trace data on a local machine or a remote machine. The rest commands are to analyze the results that are recorded. So consider the following example. It's a very simple program, just calls hello function and hello function. Calls printf with the element. So, in order to run with the Uftrace, you need to compile it with the instrumentation code. In this case, it uses PG option. And then you can run it with Uftrace record command. As you can see, it just runs and prints the hello word and then exit. And Uftrace create the Uftrace.data directory to contain all the trace information. Once you have the trace data, you can run many analysis commands. This is a replay command, and it shows the execution of the program. It shows that the main function calls hello, the hello function calls printf as we write it. Since the record and replay is very common operation to use Userspace, I added a live command to do the record and replay commands at once. And it doesn't create a data file. Actually, it creates the data file on the temporary directory, and after it shows the replay, it deletes the temporary data. So, live command runs the program and shows the replay at once. And live command is a default command of the Userspace. You can commit it and just run the program with the Userspace. It's the same. Okay. And there's a Userspace report command. It shows performance statistics of the program. It shows total time and set time and number of calls for its function. And basically it sorts the result using the total time. You can also sort set time or number of calls using S function. And I know this is not a good example since the old functions just called once, but if it's not, you can use the average time using average total or average self options to see the average or mean next time of the function execution. And you can also use another sort option to select which sort key to use. In this case, all the functions just call once, so average mean next is the same, so the result is the same. But anyway, you can use sort options to set the different sort keys. And Userspace graph command shows a function call graph of a function. In this case, the main function is used, and basically it shows the backtrace of a given function and functions called from that function. So in this case, main is a top level function, so there was no order of the main, and it calls hello function, and hello function calls printf, so it was printed in just a single line. Since each function is just one order. Okay. Anyway, if your program calls more than one function, it will have some branches in the output, so that can be called from the function. And you can omit the name of the function in the ref command, and it equals to use name, the function name. So these two commands basically do the same thing. And it also has Userspace info command, which shows the information about the system and what's the system. The first is system information like number of CPUs and memory, and system load, something like that. And process information, number of tasks, CPU time, switches, and so on. So this is just basic uses of the tool, and I'd like to introduce some more advanced uses. Uftrace comes with various filters, and first filter you can use is a test filter, but this can be used only for the analysis time, since we do not know the test ID at record time. So in this example, it just consists of a single task, so there's no difference. But when you first data has multiple tasks, you can filter a specific task to show the result. And it can be a multiple task. It can be multiple tasks. And then function filter. There are two types of function filter. And first one is opt-in filter. So using f option, you can specify a single function, and it will show that function and other functions called from the given function. All the other functions will be hidden in the output. Or if it's by record time, they are not recorded. So most of the filters can be applied at record time and record time or analysis time. The other type of function filter is opt-out filter. So it will hide the given functions from functions called from that function. So in this case, I'll opt out the hello function, and then it will show the main function as a leaf function, since it sees no functions in the main. Another type of filter is depth filter, which limits the function depth of the function call. And if you set depth of 2, it will just show the function calls the time level, and functions directly call from the time level, and other functions. This can be useful to see a higher level of function execution. And there's also a time filter, which sets a threshold and will hide small functions run less than the given time threshold. It's also very useful to see the higher level view, since usually the function tracing data consists of many small functions. So you can easily cook out the small functions. So this is filters that supported by Uftrace. And Uftrace also supports the triggers. Trigger is can do some action at a function level. So filters works as a global, but trigger can be applied to a function level. So in this case, I set the depth filter of 1 at the function.
Sorry, is the trigger executed directly while the application is running, or is it after buffering?
It's executed directly.
Okay.
So yes, so the original function has no limit of function point depth, but I set that the hello function, so it didn't record or hide the functions in the hello function. Okay. And there's a trace on trigger. It will enable the trace when it runs a given function. So as you can see, in this case, your trace started with the disable option, which disables the trace at first, and then it meets the hello function, turns on the trace. This also can be used of record time and event time. And trace off trigger is just the opposite. And there's a backtrace trigger, which is used only at replay time. It shows the backtrace of a given function. It can be useful for some cases. In this case, it will be started with disable option, and printf function turns on the trace, and it will trigger to show the backtrace of the function. So you can see the printf is called from hello and then from main function.
Are you using the backtrace library at runtime to gather that backtrace, or you're using the sequence of what happened?
I don't use the backtrace library, since it just records all the function addresses.
Yeah.
And call trigger is also used only at replay time, and just I can to find functions easily with very large output. Also, function and trigger supports regix pattern matching. In the earlier example, I used just full name of a function. So when the given function name does not contain any Azure character can be used in the regix matching, it just tries to full matching of the function name. But if it contains any character that can be used in the regix matching, we will use the regix matching. So this pattern matches with the functions. It's not started with the underscore character.
So obviously you don't use a variable name. Yes, no.
C++ programs, mainly.
Yes, it could be tricky.
After, it does consider the name handling in C++, and after it denames this program, the function name, and then tries to merge regix pattern. But there's an option to select enable or disable to name handling, so we can use both regimes. Okay. And actually, function names can be different modules. Especially you build your program with some library. The library code itself has the compiler documentation code. It will be shown in the output, and you can select some functions from this library or in the main executable with the module syntax. So in this example, the T option selects the trigger, and the pattern matching will select all matches to all functions, but it will limit it to the library functions through the PLT. So you even select all functions in the other libraries and use the color trigger to use different colors of the functions. Yeah. The related option is to just ignore the library calls and only focus functions that are in your main executables. In case you can use the and function filter option to select all functions from PLT. But in this particular example, it's much better to use no lib call option since it at the record side, record time, it doesn't try to help the PLTs. And in some cases, you want to trace only library calls. Especially the executable cannot be rebuilt, or you want to trace some existing programs. So you can use a force option, and you need to specify the full path of the executable, since the trace doesn't search the path environment. So this example traces the PWD program, which brings the record. And then you can see it calls get CWD system call and put to print the result and print the buffer.
Just about the name of this argument, you might want to call it --ltrace or something like that, because this is actually tracing all library calls. And I mean, there's an ltrace command that's much more overread, but I mean that people are used to that. Force is, I think, is maybe not clear about the intent.
Yes, yes. So yeah, this is very simple version of ltrace. You know, sometimes some people might want to use it or use the ltrace instead. But yeah, anyway, it's up with you. And Uftrace supports argument display too. With the A option, you can specify an argument of each function to be printed. In this case, a hello function has just a single argument. So the syntax is the function name after function name and then the add mark. The first argument, it assumes, it just idly assumes that all function arguments are as your integer arguments. But most cases, simple cases, will use as integer arguments. So you can see the hello program calls with the arguments. Actually, it's a pointer to the static string. And I know it's very complex when the argument contains floating pointers and the number of arguments. So it already has a way to specify the kind of syntax using the name of the register or offset to stack base. But for the simple cases, it just provides the arg1 or 2 or 3 or that kind of simple syntax to access the arguments. And then you can use other formats like string or hex numbers or characters to print the previous argument information. In this case, it uses string format. This format is very similar to what is used in the printf, always specifier. S means string, C means character, I means integer, F is float, and so on.
So in that case, is arg1 the... I was just wondering, arg1, is that like, does it tell Uftrace that it's the first argument, or that's the parameter name, like the variable name? Because you do have that information in the help executable, right? The actual names of the...
No, it's not.
Because I think with Userspace you can specify the name.
So,
The ELF information provides the name of the functions and where they are located. The dwarf information, if available, provides the name of the parameters, the typing, and everything. So here what seems to be done is that the user has to specify the argument by position because he's not aware of the name. So I suspect you don't use dwarf at all, right? So it's the user that specifies the name.
It's a future plan.
Oh, okay.
Okay. This game, actually, the name of the argument was who.
Oh.
We just specify the positional arguments. That's the first sample. And it can also possible to specify the size of argument bits for the integer arguments, like I32 or X46, 64. And you can also record and display the return value of the function. Printf prints the hello word and numeric character. That is 12 bytes.
Actually, if you want to extend that, you might want to look at the GDB syntax for print displaying variables, because there the users can override the typing and they can even print arrays of integers. So it would be good to reuse what people are actually using.
Okay, thank you. And then column tracing. With the K option, can trace column functions too. In fact, it will turn the column function grab tracer as well as Userspace tracer and record the files and display the both in sync with the monotonic clone. So in this case, printf calls you have step this call, and there's a page fault during printf. But as you know, the printf just overwrites, so it doesn't overwrite this call. But if you add a flush or turn off the buffering, you can see it calls this, writes this code. And color function also can be filtered by using module name of kernel. But syntax is a little bit different, since kernel function filtering is done by kernel, and it doesn't support register matching. But it also it supports a very limited form of block pattern matching. I know recently a patch posted to support full block matching, but it will take time to be applied. So anyway. So F option and N option of function filter in Uftrace also supported for other functions. So in this case, printf calls F stacks this code, but it was filtered out. Basically, current tracing just limit kernel functions to use depth of 1. Because I think it will be enough for most of Userspace programmers just to see the entry point and exit point of kernel functions. But if you want to look at some more kernel functions, you can also use the depth to kernel functions with the capital K option. So you can use kernel depth of 2 and see the page fault falls downgrade trial and you find AMA, handle another fault and upgrade.
Just one point. So there's an upstream Linux kernel bug that made its way into Linux 4.8 about the monotonic clock source used by Ftrace and LTPNG and perf also. For Ftrace, it's just when you specify the mono clock source, but this is, I think, what you do. It means that basically the timestamp that are gathered from the kernel are completely bogus. So the patch fixing the problem just made its way into the master branch of Linux. But it's not being cherry-picked into 4.8.1, and so the bug has been cherry-picked in all the old stable kernels back to 2.4, don't recall, 4.4 or something like that. So all the stable kernels, latest ones, as well as 4.8, they're all buggy in terms of monotonic clock source. Just so people are aware. So if they see weird things with the tracer, it's not your fault. The kernel was currently broken.
So it's in mainline kernel.
Yeah, and all the stable ones.
How long has it been broken?
A month.
Good. And our flow options, by default, Uftrace hides all kernel functions outside the Userspace functions, since it just knows the output. Most programmers, Userspace programmers, just want to see kernel functions that hold within their program. But kernel has kernel records all the functions about the task, so it will contain many functions called before the main was started. New test was started, Userspace functions. So it will be hide by default with Uftrace. But if you want to see that functions too, you can use kernel option. And as you can see, in this output just contains main function and one startup and CXA and exit. These are the Userspace functions. But there are many kernel functions out there. So yeah, you can see that with the kernel options. And visualizing. And it supports two visualization. First one is Chrome tracing, and Uftrace dump command basically dumps the trace data that was recorded with Uftrace record command. But with Chrome option, it will dump the data with the in a JSON format, which was supported by Chrome tracing viewer. So if you save it as a JSON file like this, you can run your Chrome browser and opens the Chrome tracing URL, and it will show some button to load your JSON file. And this is the output of Uftrace running a Clang compiler. The x-axis is time, and y-axis is a function called that, and it was divided as test IDs. So this output consists of two tasks. It shows the each task function and executions. It will support zoom out, zoom in, and searches, and many convenient features. you can use Uftrace dump command with flame graph option. And it can be piped into the flame graph script that was written by the graph. And we'll create the SVG output image, and then you can use the web browser or Firefox or Chrome to see the result. I think you are already familiar with that kind of flame graph, which also supports dynamic zoom in, zoom out, and search it. This is output of low-category JavaScript engine. And this is what the current state of Uftrace, and I'm thinking about extending to support dynamic tracing and some event support like SDT or ADTNG Uftrace events, and support some debugging code to display argument information or easily. Also note that the currently the argument information is available when the program is built with PG option. I'm thinking of some more filtering options and some triggers to limit and focus on the functions I'm interested in more easily. So Userspace interfaces, and there are some performance optimizations. Okay, that's it. Thank you.
Any questions?
Actually,
I have a question.
Hey,
It just woke up, so.
so the first question was, I noticed you showed both -PG and function instrumentation. Which one do you use? Which version do you use -PG, or do you use the function instrumentation for hooking into the kernel, or hooking into the functions?
What version? Version of Bible?
Well, yeah. What option to the compiler to build the arguments?
-PG or -F instrument function, which one?
You show both.
Yeah.
Yeah. Which one do you use?
Both. It supports both though.
Oh, so you can do either or.
Yes.
Have you ever tried doing F entry, just F entry?
I tried F entry, and I think it supports it.
Okay, so that's probably the fastest one of three. Because PG has overhead, and then the instrument function has a lot of overhead. So the F entry is the one that's just a single line. And, it's probably the easiest one to get the return address, and you just don't need the frame pointers to do that.
Right. And actually, there's some issue about the frame pointer about binaries.
Yeah.
So I'm thinking about the x86 and FN2 options, and as you can see, the X-ray kind of handle options for the dynamic tracing layer.
Yeah. Because it's probably easier for dynamic tracing. Yeah.
So as far as I understand, you get the timestamps in Userspace just doing POSIX block monitoring, get and monitoring, right? Have you seen any significant difference in overhead on x86 and ARM? The reason I'm asking, I'm asking about the potential lack of the get time in VDSL on ARM.
There's not one on ARM.
Only when the given platform supports architected timers. So otherwise, you are in the illegal, you have to go to.
And you need a recent latency.
Yeah. So do you kind of in your test, are you sure that it's in the VDSO, or have you tried it on a platform where it has to go all the way to kernel, and whether you have measured some overhead difference, significant overhead difference as it is?
I just just use the get time to monitor it.
So have you measured overhead on x86 versus ARM?
No.
Okay.
I know it's very, ARM has very large overhead for
Less so, as Matthew just pointed out, and in the 64-bit world, it's pretty much solved as well. But yeah, especially older 32-bit platforms will be shitty.
So I do have one question about how early you can start tracing in the bootleg sequence. So it sounds to me that your approach doesn't require much to enable tracing. Like you don't need any like daemon running or something like that. So you write to a file, I guess, but you need very minimal stuff to be able to use to trace.
I think I cannot understand your question.
So like can you, you know when you boot up the car, right? Like how soon can you start using Uftrace?
In the boot up process?
Yeah. Let's say can you do it like when you load your modules, let's say you came out, can you do it right at the beginning? Very early.
It's a problem of current implementation. I will support some demo-like programs, which was started by other program or external. But currently it's required to run it on the command line. If
I can clarify a few things. Well, I think the question comes from the context of LTTNG. So in LTTNG, I mean, there's a daemon process involved, a decision daemon to control tracing. So in your case, is it directly the application that outputs to the disk, or are you basically keeping is there a process that stays active and consume information from the application?
there's no daemon.
Okay, no daemon.
But
But
you can do it very, in my mind, like from what I see, you can do it very early in the sequence.
yes, but I mean, nothing prevents from, let's say, loading a kind of local session daemon and do the same thing. At the end of yeah, in the boot up state.
Yeah. But you know what my question.
So, thank you.
Okay, other questions? Not, thank you, Kim.
Okay.